Hey everyone, welcome back. I know it's been a little while. I got a little busy here this last few weeks, so let's just continue off where we were last time. Last time we took a look at how to solve some differential equations in the time domain. Now this week we're going to look how to do it a totally different way. We're going to switch over to the frequency domain. For those of you who have done it before, it's called the Laplace transform, so I'd suggest taking a look at what that is. We'll quickly review here. See how well does this look. So let's just say we have this function of s. We'll just say that's equal to, from 0 to infinity, e to the negative st times this function of t dt. That right there is the definition of the Laplace transform. So there we have it. That's the definition of the Laplace transform. How well does that look? That looks fine. So really quick, we'll just show how to do a quick example of what this actually means. So we'll just do the Laplace transform of 1. That is equal to, from 0 to infinity, e to the negative st of 1 dt. Pretty simple integral. It's equal to negative e to the negative st over s from infinity to, or from 0 to infinity. And without going into too much work with how to go about that, just plug in the limits. That is equal to 1 over s. So that's a quick minute and a half review of what a Laplace transform is. Here, I just printed off this sheet right here. Let's see how well can you see that. You can see that all right. Zoom in real quick. So here we have just a huge list long of these Laplace transforms. So you can just go look up any Laplace transform you need on the internet, and you can use it to help you solve differential equations pretty rapidly. So let's just take a look at how to go about doing this. So we're given this equation right here. We're given g of s. We know this is equal to 5s squared plus 24s plus 144. That's all over s squared plus 36s plus 900 times s squared plus 10s plus 169. So this is what we have. How do we go convert this this function g of s, which is in the frequency domain, into the time domain, which would be g of t? Well, first of all, just simple algebra we've learned in previous math class, we have to unadd them. So we'll just go about, we want to get into this form, we want to split it up into two separate forms. Ideally we want to get these two numbers where you can just add them to get this again. So just unadding is what I'll call it. So we know that comes in the form that looks like this. So we have as plus b over the first one, 900 plus cs plus d over the second one. Oh, I forgot the s right there, 169. So we want to get into this form right here. We also know that this is equal to this. We want to find it so that this right there is equal to this right over there. So if we go ahead and actually multiply these, if we multiply this side, find a common denominator, so we'll actually multiply this polynomial, or this bottom guy, by this one on top, and then vice versa, we'll multiply this s squared plus 10s plus 169 by this. We will get the same two, we'll get the same 2 on the bottom, which is the same as on this side. So therefore we can say that this s squared plus 10s plus 169 times as plus b plus s squared plus 36s plus 900 times that whole quantity times cs plus d is equal to this top number, because they all have this common denominator across both sides of the equal signs. So we'll go ahead and multiply these two and then these two, and then we'll add them together. So we have as plus b times s squared plus 10s plus 169 plus cs plus d times s squared plus 36s plus 900. And we know we can just go ahead and drop these, drop the denominators, because we essentially, in essence, we've multiplied them. So the entire thing's a common denominator, so we can go ahead and drop that. So we know that this is equal to this 5s squared plus 24s plus 144. So go ahead and write that. I don't have enough room to write it all in one line, but whatever. Okay, so next what we want to do is we want to go ahead and actually multiply this entire thing out. Go ahead and multiply it out. So just start multiplying the terms out. So we'll do the a's first. So we'll get as cubed plus those two terms, 10s plus times as, we'll have 10as squared plus 169as. Now for the b terms, we'll have plus bs squared plus 10sb. No, I want to write bs. Whatever. bs, there we go. And finally we'll have plus 169b. Now for the second term, we have positive cs cubed plus 36cs squared plus 900cs. Now it's time to do the d terms. We have ds squared plus 36ds plus 900d. And we know this is all equal to 5s squared plus 24s plus 144. So this looks kind of like a mess now here, doesn't it? So let's go ahead and just kind of grab all the s terms and line them all up in a nice convenient, oh wow, sorry, that wasn't in focus. Let's line this up in a nice convenient form to do. So we'll start off with the s cubes. So we have I'll just write the coefficients down. So for s cubes, we have a single a going across, we have a c. Okay, and then on the other side of the equal sign, we have no s cubes, so that's equal to 0. Now, let's do the squared terms. So for s squared, how well is that showing up? Sorry, having trouble focusing this today. For s squared terms, we have a 10a. I'll just drop the s squared again. And looks like we have a single b. And moving across, it looks like we have a 36c. And going across some more, it looks like we have a positive d. So the next one, we have our s term. Looks like we have 169s. Try to write bigger now. 169s, or 169a, I should say. The s is right there. We're dropping the s terms again. And moving on, we have 10bs. 10b, let's go across more. Looks like we have a 900c. And let's look at our d term. It looks like we have a positive 900d as well. Okay, finally, let's go to our next term. Oh, sorry, excuse me. This is weird. Did I multiply it wrong? No, this does not have an s on it. I should not need that. Sorry about that. Looks like I'm missing a term. Yeah, I need a 36ds. There we go. Now that's right. So now for our s to the 0th terms, it looks like we have nothing in the a's. 169 for the b. Now let's go to our next one. It looks like there's a 900d. Okay, it looks like I forgot to set them on the equal side, so let's go back and do our s squared. So our s squared term has a coefficient of 5, our s has a coefficient of 24, and then our s to the 0th power has a coefficient of 144. So there we go. This is what we have to solve for. We have to solve for a, b, c, d. We have these 4 equations, 4 unknowns. Looks pretty easy. So easiest, my personal favorite way, because it's really easy to do on a calculator, is just go into the row echelon form. So we'll just go ahead and start writing these coefficient matrices. So we have a, b, c, d in this matrix. So we have 1, 0, I'm not writing this very well, b, c, d. So there we go, we have no b's, we have a single c, no d's, and that's equal to 0. Next one, we have 10 a's, 1 b, 36 c's, 1 d, and 5 on the other side of the equal sign. Next row, we have 169 a's, 10 b's, 900 c's, 360 d's. Oh, 36 d's. D looks like 360 for some reason. And that's equal to 24. Finally, we have our last one. We have 0 A's, 169 B's, and we have 0 C's, 900 D's, and that's equal to 144. So see there, we have that matrix right there. Now we just have to do the row echelon form. I won't waste time going into that because it's a lengthy process, but something a computer can do really quickly. So already did that. So from this equation, we know that, or once you solve that, you find out that a equals 0, b equals 6, c equals 0, d equals -1. So there we go. We have that. Let me switch pages real quick. For some reason the camera does not like focusing on the front side of this paper, so I have to flip it over. Okay, so now we have it unadded, so let's go ahead and just rewrite what we have so far with our coefficients. Remember we said we had it in this form of as plus b over s squared plus 36s plus 900 plus cs plus d over s squared plus 10s plus 169. So this is the form we want to get it in. We already know what our a's, b's, c's, and d's are. We found them right there. So let's just go ahead and plug them in. So we know that a is 0, b is 6, c is 0, and d is -1. So let's rewrite that to make it look prettier. So we have 6 over s squared plus 36 plus 900 minus 1. Just take the minus sign from that -1, just call this a positive 1 and that a minus instead. Same thing. S squared plus 10s plus 169. So this is our unadded form right here. That is equal to our g of s. So let's go back to our trusty chart right here. So it looks like we have no s's in the top. We only have s's in the bottom. So let's look here and kind of look. Basically what we want to do is we want to adjust what we have to make it look like something that'll be useful to us. So what does it look like we have useful to us? Well, it looks like this sign will be useful right here. Looks like this one will be useful because it's kind of like we might be able to get into this form. So let's go ahead and actually try that. So how do we get into that form? Well, it looked like we had an s squared plus w on the bottom. This is not in that form, so how do we go ahead and do that? Well, let's complete the square real quick. So we know that this 6 over s squared, what is half of 36? That's 18, so we can go ahead and write s plus 18 squared. And then half of half of that is 18. 18 squared is, what is 18 squared? 18 squared is 324. So we have 900, we'll just do a map here, 900 minus 324. So 900 minus 324 gives us 576. So let's take the square root of that. And hey, oh what luck. So the square root of 576 is 24. So 576 square root equals 24. So that's equal to 24. So we'll just go ahead and write 24 squared right here. You might be questioning, oh, sorry about that. You might be asking, why did I take the square root of that? Well, you'll find out in just 1 second. As you recalled, we had that s squared plus w squared, so we have this w squared term here, so that's helpful. So now let's do it for the next one. So we have a minus 1 here. We'll forget about the 1 for now. There's a minus. So we'll complete the square again. So half of 10 is 5, so we'll write plus 5 squared. Let's see, what next do we have? We have 5 squared is 25, so 169 minus 25, I believe that's 136. No, 144. What was I thinking? And the square root of 144 is 12 squared. So we have it in this form now. Let's compare it to this form now. So it looks like we successfully got it into something that looks like that. But wait, oh my gosh, look at that. This term looks even better because it looks like we have this A and we have a W. The only thing we do not have is a W on top. So just let's look at the similarities between these. So we have, I'll just write it down on this piece of paper so it'll be easier to see. So we have this identity right here that you can just print off on the internets. So we have e to the negative at sine omega t is equal to w over s plus a squared plus omega squared, or w squared. Omega, I don't know what it is actually written on this paper. It kind of looks like a w to me. So we have it in this form. Look at that, it's almost identical. We can almost go ahead and write down the answer. The only thing we need is we'll need either a 24 or a 12 on top. So what do? We do just that. We add a 24 or a 12 on top. So let's go ahead and write down our final step before we can write the answer. So I'll just rewrite this again. So I'm going to pull this 6 out. This 6, I'm just going to kind of move it out for now. So I'll move that out. And then I'm just going to go ahead and cheat and put a 24 right here. Well, that'll be a multiplication symbol. So we have s plus 18 squared plus 24 squared. Well, I added a 24, so what do I have to do? I can multiply it by 1 whenever I feel like it in most cases, and I multiply by 24. That's not good, so what do I have to do? I actually have to divide by 24. Sorry, excuse me. There we go. So we can just take this 16/24 and we can kind of put a shit off to the side and ignore it for now. Next, what we have is we have a minus 1. We need a 12. So I'll just put this minus 1 out here and I'll just add a 12 because I can. So that's s plus 5 squared plus 12 squared. And because I added a 12 on top, I have to divide by a 12 as well. So there we go. We pretty much got in the form that we want. So we'll just kind of ignore this negative 1/12 for now, and we can go ahead and write the answer. So this answer is equal to 6. Let's zoom out real quick. There we go. So it's equal to 6/24. And then we're just going to go ahead and plug this form right there. So this right there is, we have our A right there, and our A happens to be 18 right here. And our W is 12 in this case. No, 24. 24, what am I thinking? So we'll go ahead and write it. So it's just equal to e to the negative 18th t times the sine of 24t minus 1/12 e to the negative 5t times sine of 12t. There we go. It looks like that is everything. we have successfully converted it to the time domain from the frequency domain. So that is how you go about converting it over to a time domain. That was kind of a pretty generic example. It was kind of not real practical in the sense. I think I hit the time limit for what YouTube will let me upload, but next I'll just go ahead and show you how to actually apply this to a differential equation like that you saw, that you traditionally see. So with that being said, that's it for this one. I will go ahead and make another one using another example using something that you more likely see, which would be just a second order differential equation, how you go ahead and use the Laplace transform to go ahead and do that. So thank you very much. I will see you in just a little bit.